Hello YouTube, Gadget Boy here. Taking a quick break between ionizer construction videos while I figure out my next step and wait for my next paycheck so I can buy some parts. Just wanted to show you a little adventure I'm having with a cheap little USB charger that I bought at 7-Eleven, of all places. Was at the airport with a friend. My phone was dying. I'd not remembered to bring a charger, so I picked up this little $6 job. And it worked for about, I'd say half an hour, and then just quit out on me. So when I got home, rather than throw it away, I decided I'd take it to bits and see if I could figure out why it no longer functioned. It's actually a pretty decent charger, all crammed up into a very, very tiny little package here. I've already opened it up. It took a bit of violence to get it open. Hopefully I'll be able to get it back together, assuming I can get it working. So you got the mains voltage coming in here. It's going through a little bridge rectifier package there. Let's see. Not too sure where the traces are going here, but it looks like we've got big smoothing cap here. Not too sure what that little chip is. I'd have to look it up to figure it out. I probably should have done that before I started the video. Once it's done with the smoothing capacitor, it looks like it's dropping through this transformer, probably dropping that down to a mere 5 volts. Maybe some isolation capacitors here, and then the 5-volt side of the charger's very well, except for the fact that it's mashed up against it like this inside the package, but it's got a nice long cable isolating it from the AC side. Looks like another smoothing capacitor here, a diode to make sure everything's flowing in the right direction. Looks like a couple of current limiting resistors to keep the current at a manageable level. I wonder if that means I could mod this to put out an 1.5 amps or even 2 amps. Interesting thought. I'll have to examine these components and see if I can do that without letting the mysterious blue smoke out. Anyway, so that's the basic work of basic charger. You get your mains voltage, turns it into DC on this side, drops the voltage, and then feeds it out into your USB charge port here. So I'll go ahead and go show you that it definitely doesn't work. Just gonna carefully plug this into this power bar here, kind of a manky little power bar. And this is a neat little USB charge indicator here. So we'll just turn this on, and you can see that, oh, that's a new symptom. It wasn't doing that before. Does that actually show on the camera? Yeah, it does. So you can see that the charge indicator there just kind of feebly flashes, doesn't even get to start up. Just gonna make sure that those capacitors won't give me a zing. So I'll quickly show you with this charger. This is a known good charger. When it gets plugged in and powered up, you'll see, wow, well, maybe that's not a known good charger, only 4.9 volts. But you'll see it starts putting out 4 volts there. Another cool feature of these little units, I'll show you real quick by plugging in this USB power bank. It also tells you how much amperage is being pulled by whatever device you have plugged in. So this power bank is pulling 25 milliamps, which means it will take actually quite a long time to charge that thing. So, you know, that's a way to test that we know for sure that this this charger isn't working. So I was kind of hoping to find a smoked component, or something that was burnt out and meant that it had failed spectacularly. But upon examination, when I upon examination, when I opened up the package, we'll just show you here. You can see a great big dent in the side of that capacitor there. And I think that that is probably our culprit right there. Probably would have worked for a while, but as it heated up, the layers inside the capacitor would have started shorting out, and it would have failed. It didn't fail spectacularly like electrolytics are sometimes wont to do, but I think that's where our problem is. So I've got another 470 micro 10 volt, yeah, 10 volt electrolytic there that we're going to replace it with. It's the exact same component. So we're going to start, pardon me while I rattle around here for a Sharpie of some sort. Is this the working one or the bad one? That's the bad one. You'd think I'd throw these things away when they stop working. Sharpie, you need a Sharpie. Oh, we'll use this one. So I'm just gonna mark well, it kind of shows. I'm gonna mark which side of the capacitor there is the negative side, so that I don't get them mixed up, because then we will have a spectacular failure on that component when we put voltage on it. So I'm just gonna, I already have my soldering iron hot here. We're gonna try to desolder this this capacitor here. Might prove to be a little challenging. Sometimes these boards, because they're, of course, they're forced to use lead-free solder, which is really not the most pleasant stuff to work with when you have to do repairs on a component. So I've just got my desoldering braid here. I'm actually going to cheat just a little bit. And just dab a little extra flux onto that. Flux, as I mentioned in a previous video, is a mildly acidic mixture of chemicals that's mostly tree sap, pine sap specifically, with a bit of an emulsifier to encourage solder to flow. Not too sure exactly why it works, but it does, so I've never really asked any questions beyond that. So we're just going to try to soak up this solder here with the desoldering braid. I was afraid of this. Alright, so that's not working too well. So we're going to try another trick. Seems counterintuitive, but we're going to add a bunch of lead-bearing solder to this joint. Let's try to offset the crappy lead-free solder. And then we're going to try soaking it up with the braid again. Pardon me as I... There we go. You can always tell when the desoldering wick has worked properly, because the solder just shoots into the braid. And now, just gonna hopefully works this the rest of the way free. It's just a little bit more stuck in there. Come on, you. I just realized I'm doing this all off camera and it's very boring. Ow. Come on. There we go. Alright, we'll add a little bit more solder again. So we're going to have to clean those holes out. Grabbing the wick, dabbing it with some flux. There we go. Thing of beauty. Although I think I just burnt a hole in my desk. But that's alright. So, now we've removed the bad component. I'm going to reach over here. Maybe. What do I do with it? Oh, there it is. So reach over here, grab my multimeter. I'm going to take a reading on this capacitor just to... Oh, actually, I'll use my fancy reader. We're going to take a quick look at this capacitor using my component tester here. Assuming the leads are long enough. They are? Alright, let's see what my component tester says about this cap. Testing. Well, it identified it as a capacitor, and it identified it as 423.7 micro. Interesting. So despite that big dent, it would seem that, well, 470 micro, 423, that's a pretty big variance. Let's see what this cap says. This is the replacement that I grabbed. Stick that in there. Fix this again. Testing. It says 590 micro. I think I need to recalibrate my my tester here, because that's supposed to be 470. But if a 470 is testing at 590, and this 470 was testing at what was it, 423, something like that, that's a sufficiently large variance that I feel that this is probably pretty much shot. So let's try a different measuring tool here. We'll try this multimeter. Oh, come back here, you. What does it say about this capacitor? It says something completely nonsensical, 1.60 micro. That's not a good sign. Why am I getting such erroneous readings on these? Uh, 3.279 nano, that can't be right. Interesting. I wonder why I'm getting such an erroneous reading with the multimeter here. Let's see what this one says. This one's going to be exceedingly difficult to measure. carefully here. There we go. I think I'm of the opinion that something is wrong with my multimeter here. I'll have to diagnose that a little bit more later. Anyway, let's move on. So I don't see any other really obvious damage on this board. There's a possibility that little weird 7-pin chip might be damaged, but we're just going to try swapping out the capacitor here and see if that fixes the problem. So now I remember marking the appropriate side here to maintain the polarity. Alright, I'll just fold that over so it's nice and tight. And then we'll flip this over, grab the soldering iron, and quickly drop a little bit of solder in there. Cooperate you. Oh, my head's probably in the way of the camera here. Alrighty. Nice solid solder joint there. Now, before I clip these leads, because if it's not the cap, I don't want to waste a perfectly good cap on this project if it's not going to fix it. So let's plug this back in. What I do with my tester? There we go. Do that. Make sure those leads aren't shorting out onto anything. Let's see what happens now. Hey, look at that. It was the cap. We got nice solid 5 volts coming out of that machine now. So if I plug this in, that's that power bank. Oh, out of this charger it's pulling 33 milliamp. So that project has been successful. Now I'll just quickly short these and short that. Generally these will come with a discharge resistor in parallel with the filter caps, just so you don't light yourself up. But it's always a good idea to ground the, to short the leads on those caps, just to make sure that you don't give yourself a little zing. In fact, in my DC electronics course that I took at Metropolitan State College of Denver billion years ago, the instructor was fond of leaving charged capacitors lying out on the workbench. Every now and then you'd see somebody go, "Ha!" as they picked up, oh, hey, it's a capacitor that's just lying out, and they'd grab it, and it would discharge into their fingers. And he always thought it was really funny. We had other opinions on that. So anyway, now I get to try to figure out how to... Whoops. Well, it looks like I get to try to figure out how to fix this ribbon cable, which I just broke when I picked it up. I'm going to do that off camera though, because you guys probably don't really want to watch that. And I'll have a working charger when I'm done. I just got to fix that ribbon cable. I'm probably going to have to use new wire. Alrighty. Anyway, thank you for joining me on this somewhat rambly little exploration of a broken cheap charger here. if you liked it, do that thing you do when you like videos. I am actually trying to get a custom name for my channel, so my goal for that is 100 subscribers. I don't want to beg for subscribers, but apparently the way YouTube works, you eventually have to beg for subscribers at some point. So in order to get a custom name for my channel, I will be needing to hit that 100 subscriber mark. So share my channel with your friends, and let's see if we can hit that goal, and I'll do something special for you guys if we hit that goal. So I'm hoping to get the, well, not the remaining parts, but the parts that I need for the next part of my ionizer video here in a couple of days, and I'll have that uploaded, and I'll see you then. Again, thanks for watching. Bye.